All right, welcome everyone. Thank you for joining us today for our third day of the main conference track. We have a cool thing ahead of us. I'm really excited that you're here to join us because this is a lot of effort's gone into the planning of this particular session, which features a whole lot of people. And in a moment, I'm going to hand you off to Maytal Dahan, who is a co-PI for the Science Gateways Community Institute with me. But before I do that, I want to get your fingers practiced with writing things down. We actually would like you to use the, I'm going to just share my screen for real quick here. So as you know, if you are here in this meeting, which I forgot to update with conference update, so I'll do that in a minute. But if you're in this meeting here, you'll see that there is a section for questions from you guys in the for the panel. And I encourage you to put your questions there. If you forget and you put it into chat, that's okay too. I'll put them in there for you. But we would really like you to, we encourage your questions, we encourage your participation, and we hope you'll just use this shared Google Doc to do that. And also you're welcome, of course, to add any notes or resources or things that you think of in the takeaway down here, takeaway section down here. In addition to that, I want to ask you a question because I don't know about you, but I'm working from home and I don't have any coworkers here except for my 11-year-old and my husband. And so what I'd like you to put in chat just to get you warmed up is if you were going into the office right now and you had just finished your conference, would you what would you tell them about that you have experienced so far that you think is worth sharing? I will tell you what mine is while you think about what it is that you would want to share with your coworkers. I would tell, well, what I actually told my son about yesterday was the hilarious video that James Brian Graves did about Hub Drive. So when our conference recordings from the concurrent sessions are posted on YouTube, I really encourage you to go and see that because it was really just about the most hilarious conference presentation I have seen, and it tells you all about how Hub Drive works, such that someone even like me can understand it. So, so if you we'd love to have your comments in the chat about what it is that you have had as a takeaway so far this conference that you would share with a youthful member of your co-working staff, like kids, or your spouses or partners or roommates or whatever, or cat, whatever. So share that with us as you're getting warmed up for this event. So with that, I'm going to hand off to Maytal. So you want to unmute, be sure to unmute.
Good morning. Hold on. Apparently all the practice still didn't seem to work appropriately. Share my screen. Okay, hopefully everyone sees that.
Looks good.
Great. Okay, hi everyone. Welcome to Gateway's 2020 Tech Summit and Gateway Interoperability session. As Catherine mentioned, my name is Maytal Dahan. I'm one of the co-PIs of SGCI, and I manage the Scientific Software Collaborative Group. Our group is in charge of the Gateway Catalog, which you should all check out at catalog.sciencegateways.org, and this new effort that I'll introduce today that we call SGCI Tech Summit. As many of you already know, the broader goal of SGCI is to help solve common challenges faced by the Science Gateway developer community. The SGCI Tech Summit launched after the Gateways 2019 conference, consisting of individuals from a number of different institutions and Gateway projects. This group identified Gateway interoperability as being one of the key challenges facing the community. And in this plenary session today, we'll start with an introduction on the Tech Summit and this groundbreaking effort. I'll go into some of the broader goals and how you can help us achieve these goals. And next, the SGCI Tech Summit team will describe their current Tech Summit initiative, and the project members will give an update to the community on the progress that's made so far. Lastly, we'll have an engaging panel consisting of Tech Summit members and national and international leaders of the Science Gateway community to really share their experiences and challenges with Gateway interoperability and help ensure that this effort is more successful. So as Catherine mentioned, please think of some engaging questions that you might have and add them to the Google Doc, and I'll try to get to them throughout the panel. Okay, let's get started. So looking back on the services we offer, briefly mentioned on Monday, we see that our community program has reached over 2,000 participants, and we've completed more than 100 consultations. And while this has been a great experience, it leaves an open question of what's next. Other than having helped you accomplish your goals, what else can this competency at outreach and experience from consultations do to help the community? There's now an opportunity to do something that we couldn't have done in our first few years. Between these two main activity areas of the Institute, there emerges a possibility for a new activity that we call Tech Summit, with community-oriented goals of sharing these experiences and using them as a focal point for community activity. So I don't know if you could tell, Mike really likes the ant metaphor, so I'm going to kind of stick with that throughout my slides. The Tech Summit really started with 4 goals in mind. 1 is to provide leadership and community engagement. 2 is to impact the future of Science Gateway software by leveraging an SGCI team that has really deep knowledge of the gateway software landscape and is looking for ways to make the greatest impact on gateway software to help ease the burden of creating gateways and serving a broad landscape of the community. 3, to bring together architects of gateway technology so that we aren't doing things in a bubble. 4, converge on ideas and technology platforms to be as productive, efficient, and sustainable as possible. These 4 goals set a framework for having a tech summit that is a breakthrough effort for SGCI and continues the need to collaborate with the gateway community. And the goal is to really maximize the impact for both SGCI and the gateways community on the future of CI. But the broader goal of the Tech Summit and what we envision being a transformative effort is to create momentum within the gateway community on opinion pieces seeded by SGCI and authored by the wider community, and subsequently have software development activities that put those ideas into practice. The bigger goal of the Tech Summit will be multiple efforts that push the envelope and attempt to achieve maximum impact on the future of CI. This really requires you. As Mike mentioned on Monday with Connections, the goal is to use the Tech Summit as a connection that causes conversations to flow between SGCI and the community that make a measurable impact on our landscape. Our initial project selection that you'll hear about today is this application description language. So I'm going to go ahead and pass it on to Joe, Suresh, and Daniel, who will deep dive into this project.
Awesome. Thank you, Maytal. Let me share my screen. Hopefully you see that okay?
Yep.
Cool. Well, hello, everyone. Yeah, my name is Joe Stubbs, and I'm joined by my colleagues, Suresh and Daniel. And today we're going to be talking about this first Tech Summit project, which focused, as Maytal said, on interoperability across cyber infrastructure and on designing and implementing a resource inventory system. Let's see if I can get these to advance. There we go. So I'm going to start off by kind of framing the challenge and giving a kind of high-level overview. And then I'm going to turn it over to Suresh, who's going to get into a bit more of the technical design and implementation details. So first, the challenge. You know, we look around and we see lots of cyber infrastructure, you know, lots of Science Gateway technology being developed. There are over 600 registered systems in the SGCI catalog that Maytal mentioned, and over 20,000 active Globus endpoints, for example, right? So we see lots of activity in this community, but we see very little interoperability across the systems. And there are kind of 2 main problems that we see with that. First is that gateway frameworks end up re-engineering solutions to the same set of problems, right? This is authentication and authorization, data management and movement, application execution. They keep reinventing the wheel. But secondly, and perhaps even more importantly, is researchers, the ones who are actually using the gateways, end up kind of getting locked into particular platforms. And oftentimes it's quite challenging. It's quite an effort to move from one platform to another. So we thought that, you know, if platforms were interoperable, then components could be reused and we could potentially avoid lock-in. So what does interoperability mean to us? What did we kind of think about when we were starting this project? Well, we see analysis, you know, running codes as essentially fundamental to all computational research. Most gateways offer some kind of analysis in the form of code execution. So the ability to define application codes in one gateway and then execute them somewhere else on another platform seems like it would open up a lot of possibilities. But when you kind of begin to sort of dissect this problem, what you quickly realize is that resources, the actual computational resources where jobs are going to run, become essential, right? So for instance, if you want to run a job, you must know where the inputs to the job run, where the inputs to the job reside. You must know where to run the code, and you must know where to archive the outputs of the job once it's complete. And so each of these wheres is a resource. You know, it's a computer, a machine, or maybe an API. But without a description of these resources, we really can't have a chance describing the jobs themselves. So we started with that. And you may be asking, you know, aren't there standards for this already? Well, yes and no. So on the one hand, there were standards that kind of were started in the past, but never really took off. These are things like Drama and Glue. There are also current efforts, you know, that are great technologies, right? Things like Redfish for resources, common workflow language for applications and workflows. And like I say, these are great technologies, things that some of us even are using in some of our projects, but we found that none of these were really perfect fits for science gateways. They weren't really built necessarily with science gateways in mind. And the fact is that none of these has really emerged as a standard or honestly made significant inroads in general in adoption in the gateway community. You might think, well, hasn't this already been tried before? You know, grid computing, that didn't really work out that well, right? And that is true. That's true as well. But that was over a decade ago. And the technology landscape really has changed substantially since then, right? In particular, the portability of computing has become this more fundamental paradigm. And in particular, it's part of cloud computing that has become really, you know, has seen real substantial adoption in both academia and industry. You know, we have other innovations, right? Like the emergence of HTTP APIs, you know, microservices, associated standards like REST and JSON, containers, the OCI, and associated technologies that really help achieve computational portability. And at the same time, there's a motivation, right? Big data problems are now prolific. Just about every domain has one. And very oftentimes, big data problems require moving the compute to the data. And so we have this motivation as well to solve these problems. So just briefly before I turn it over to Suresh, our high level approach is essentially the following. We went about defining a schema for describing resources, a sort of uniform resource description language. And we chose JSON schema for that, which if you don't know, JSON schema is just a technology, you know, a vocabulary for describing the permissible set of JSON objects. And so we wrote this schema with abstraction levels and terminology that gateways naturally use in mind. So we have things like storage and compute resources. We have connection protocols like SSH and HTTP, and security protocols, and so forth. And so our idea is that by targeting the science gateways community and the terminology and the abstractions that they naturally use, we have a better chance of success. Okay, so that's it from me. I'm going to stop sharing my screen and turn it over to Suresh now.
Thank you, Joe. Can you see my screen okay?
Not yet.
How about now?
Yes. Yep.
Right. Yep. Thanks, Catherine. Yeah. As Joe described, like I think the goal, like just extending on the goal, and then before we dive into some details here, one thing as we looked at the past experiences in developing similar efforts, like one thing we wanted to do differently is first, like put lots of emphasis on the adoption. We didn't want it to become a standard body where we claim that we cover all the aspects of computational resources to start with in this case, and then go into a phase of how to use that schema. So instead, we wanted to do it. We start out with a very minimalistic one. So yeah, start with the minimalistic schema, and then facilitate community adoption and as well. Let's start using that and then see with an applying some open governance principles, how can we let projects come and contribute as we go. That's we thought that's a better way of instead of going and developing a very comprehensive schema, because we never can get it right. There's always be corner cases, there'll be advanced cases and specialized cases. So the way we approach it is the first thing to so for some of these goals, we were brainstorming quite a bit on how do we do this community adoption, how do we develop an open governance model. And then we decided, instead of reinventing a wheel, instead of standing up database services and then figuring out who has the right permission to commit to those databases, who will run those services, and who has the permission to author it. So we thought, okay, why not all of us are developers, and this is a tool we are targeting the gateway developer community. So we thought we'll just use the familiar Git ecosystem. So the idea was we started out with describing the resources at the Exceed resources. So started out with the TAC, SGSC, IU, PSC, and some campus resources, which some of the frameworks are using. Started describing those resources and push those description with the schema Joe described into the Git. So here the idea was Git is already everyone is familiar with how to use the Git as a persistent store, and it somewhat qualifies for the FAIR principles. Not that was not the complete goal, but the idea is it's once we put artifacts into the Git, they are discoverable, they are searchable, and GitHub commits to maintaining the persistence of it and so on. But the more important and the bigger goal which attracted us was the community is already aware of when you go on find a public Git repository, how do you create issues and request for others to contribute, draw others' attention on what they would like to add, or if they have a need, they can submit pull requests, and there is a process, and also there's a lot of tooling around it. For instance, how to do schema validation. We can have a continuous integration tooling like Travis CI. Just before any pull request is accepted, we can just make sure that's why it validates against the schema, or even we can do even further advanced checks does this description really work? So once we decided the GitHub will be our persistent store for the describing computational resources and persisting those resource description artifact, then the next goal we were thinking was how do we envision gateways using this schema? So the first thing was obviously Git is a way you can pull the code and deploy, but Git is not designed for pulling it thousands of times a day by each of the gateways, and it's not. And then the GitHub APIs for sure, rate limits, and so on. So we thought, okay, we'll introduce a cache in a MongoDB, picked up a MongoDB because, as Joe described, the schema, we picked up JSON. So Mongo works well with the JSON schema, directly putting those documents as is. So we thought we can write GitHub hooks and push all the entire repository artifact into a Mongo database and provide an API and how to retrieve these documents, and then the service need not be a centrally hosted service. And we made this as a software. Anyone could download this lightweight service, an API service and a Mongo database, and configure a hook. The database gets the hook and then provides the API. So the way we are envisioning this is each of the gateways. For example, the way we are prototyping right now is Daniel has been prototyping and are looking into how the Hub0 and NanoHub and Hub0 based gateways and NanoHub can use such kind of resource description, and the Tapis framework, the Apache Airavata framework, and then you'll hear following the talk some early efforts as Open on Demand and other projects are starting to look into how this could be used. And as we started to look into how do we pull artifacts, we wanted to even explore APIs, instead of there'll be lots of documents, and the REST APIs was a natural choice, to get the standard all the REST operations, but we wanted to also facilitate more advanced queries. Not all gateways will require all the fields. Once you are developing the standards quickly, as a community resource, it will keep growing bigger. But not all gateway frameworks might be interested in everything. So we choose, and we ended up choosing GraphQL, where each gateway framework can pick and choose what they're interested in. So like, for example, on Stampede 2, at a given time, I might be only interested in how to submit a job to Stampede 2, or how to move data to a Bridges computer or Expanse, the next generation one. So the gateways can specify the fields they're interested in and then pull those data sets out. So the full workflow is as we see, like, we are seeding this project with the HubZero, Tapis, and Irauta projects, putting all our current resource descriptions into a common place, and then we pick those schema elements which cover those descriptions, and we push them into a GitHub. And then when new description come in through a Git hook, the respective Mongo databases gets updated. Today, we are envisioning each of these frameworks have the deployment of this database. Essentially, the GitHub will now push to all the artifacts to the respective frameworks local database cache, and now the gateways through their can integrate through a GraphQL interface into the respective places into the frameworks where you're touching the resource descriptions. So this is the current full life cycle. The resource description will be a community source. Like if you see a resource being missing, we expect you will contribute a pull request. The resource comes in, and the framework will need it. Like it can query, oh yeah, I'm looking for a resource in University of Nebraska, and yeah, this is already there. So I'll start pulling in and try to use it. And if it doesn't have some of the fields, I'll raise an issue or submit a pull request. So this is our what we are envisioning here is we created a community platform. There is no single entity responsible for running, so there is no single point of failure. That's the GitHub. We assume GitHub has to run here, but like the GitHub will be this persistent store, and each gateways, as they run various services, they will be responsible for running the database services as well. So again, we've been describing the bigger picture so far, not get into the schema details and all. The idea is we have a learning lab proposed after the break. We'll have a learning lab, and that's where we can look into and walk through some of those descriptions, how the schema looks today, and how the Tapis, Irauta, and HubZero frameworks are exploring integration into our production environment. So the workflow is simple. The schema and resource definitions are available in the GitHub, and then the API could be deployed. And then as new APIs comes in, you can submit a pops-up kind of a mechanism. You'll get updated, and the rest of the gateway operations will function the same. So we wanted to start out with this simple one and then move on into the application cases as we go on. So everything is available in the GitHub repository. If you go to github.sgci, you'll see the resource inventory itself. That's where you'll see the schema in the JSON schema. And then if you look into the cache surveys, you'll find the MongoDB deployment and the GraphQL deployment, like with some installation instructions on how to deploy that. As Joe described it, and as I was trying to repeat it, by no means we are claiming this schema is complete and comprehensive, but the idea is that was our idea. We want community to speak up and say what you will need. Do you have it? If not, we eventually want to foster an open community approach here to manage these schemas. So with that, let me stop here and take any questions. And then again, remind you that there'll be a learning lab where we'll be happy to go into some more technical details and walk through some of these documents. So I'll stop sharing and so that I can see all the faces, and we'll be happy to take questions here.
And just as a reminder, you can put those questions into the shared Google Doc and in the Kiko chat window if you want, or you can put them in chat and I'll move them over there for you.
Let's go ahead and move on. Thank you so much, Suresh and Joe. And as Suresh mentioned, there's going to be a learning lab right after this, which you can go ahead and meet the developers that have been working on the Tech Summit and kind of have a more in-depth discussion with them. Also kind of thank you for the wide, broader team that's been working on this Tech Summit. It's definitely a collaborative effort. So now we're going to go ahead and move on to the panel. As Catherine mentioned, please post your questions on the Google Doc, and I'll also try to keep track of the chat box, and I'll get to those questions throughout the panel. So let me introduce our panelists. So JP Navarro is from the University of Chicago and Argonne National Labs. He joins us from the Exceed project. He works on the Resource Discovery Service and will share some of Exceed's efforts on information services. Eric Franz is a software developer and tech lead of the Ohio Supercomputer Center Gateways team and is on the Open on Demand project. Thomas Kiss is a professor of distributed computing at the University of Westminster in the UK. Thomas leads the Research Center for Parallel Computing, focusing on core cloud computing research. He's been involved in the Science Gateway community for over a decade and chairs the European edition of the Gateway Workshop several times. Joe Stubbs is the manager of the Cloud and Interactive Computing Group at TAP. He's also lead PI on the TAPIS project and helps lead the effort, the Tech Summit effort with Suresh you heard about. Suresh is from Indiana University and is a Gateway architect and SGCI Extended Developer Support Consultant. And lastly, Daniel Mejia is a senior software developer for the Network for Computational Nanotechnology at Purdue, and he's been involved in several cyber infrastructure projects at NanoHub. So first I'm going to go ahead and ask questions of our panelists to get a better understanding of their experience and their background, and then I'll open it up for audience questions. So JP, I'm going to start with you first. If you want to go ahead and share your slides. What is the role of Exceed Information Services in fostering interoperability for cyber infrastructure frameworks such as Science Gateways?
Hi, can you hear me?
Yes, we can hear you and see your slides.
So thanks for the opportunity to share a little bit about Exceed's Information Services. Before I get into that, I just wanted to remind everybody that as a distributed infrastructure, Exceed is always looking for ways to engage with Science Gateways and other developers to provide interoperable security, data, resource discovery, and execution services. So our scope is very broad as far as wanting to integrate and needing to integrate with other software and service providers in the ecosystem. But more specifically with the question that Maytal asked regarding information services and even narrower than that on the area of resource discovery, which is a topic that we just saw presented. Exceed fosters interoperability by offering public resource information and discovery interfaces. So we do this using our information services, which aim to be the authoritative source of integrated resource information across Exceed. So for all of our stakeholders, whether they are users and researchers, whether they are internal or external developers, and whether they are internal or external operators, we gather information about resources from multiple sources. And that chart on the right of my slide shows that what we do is we gather information that may be coming in from systems where it's entered by hand. And we also gather information that may be gathered programmatically by running software on specific resources and gathering information that's available on that machine. So we take that manual information and we combine it with automated information. Sometimes most of the information is entered manually, and sometimes most of it is gathered automatically. And we have to be flexible enough to gather all of that information. We then clean up that information, we merge it with other information, and we put it into standard schemas in a central service. And then we provide standard APIs so that clients don't need to worry about where the information came from. So the same piece of information about one resource may have come from a database where it was entered by hand, but from a different resource, it may have come from somewhere else where it was collected automatically. And that it might be the example in the case of Exceed, where we have a database where we maintain resource descriptions, but other systems may not have a database and they just want to manually register something from their catalogs, perhaps. Now, it's important to recognize that, that although I'm talking here about gathering resource information, we have to find an architecture and a solution that doesn't just work for resources, but also works for software information, for network services. So for cataloging our enterprise services or the science gateways available within the Exceed environment, and other types of resources. So in information services, we have to deal with a broader scope. It's definitely true that both SGCI and Exceed aim to provide resource inventory information. So we really appreciate the fact that SGCI is working on this, and Exceed is also very interested in working in this area and has been for years, and we look forward to the opportunities to work with SGCI on the area in the topic of resource inventory discovery. So information services can advance gateway interoperability in I think 4 primary ways. We can share with SGCI and the community what Exceed's resource inventory needs are. So we bring our own set of needs, I'm sure. We also can collaborate with everybody on defining those standard schemas, for example, and we're interested in doing that. We can collaborate with everybody on implementations. So we have software implementations that we can that are open source, and we're willing to share those with anybody who wants to use them. We can contribute to the implementations from SGCI and others. We can adopt the implementations of others. In fact, Exceed tries to adopt solutions from others whenever possible instead of building our own. And of course, we're very much interested also in just making our solutions and other solutions from SGCI and others just simply interoperable. That would be great. So, that includes, of course, also making the production components that Exceed has available to everybody else. So this is actually the case already. So, for example, Exceed's resource description repository, which is a web-based front-end application where service operators enter their resource descriptions for the Exceed resources. So this service is available to others outside of Exceed, and people can enter their descriptions for resources using RDR. The system we use for collecting information automatically, IPF, is also open source and available to the community. And then our central services, which leverage both the Bluetooth schema and some central catalogs and APIs, are also all open source and available to share with the community. So we are interested and open to continuing to collaborate with SGCI and others in the area of resource discovery. That's all I had. Thank you.
Thanks, JP, for that really engaging and thorough answer about the work going on in Exceed. If you can stop sharing. Next, we'll go ahead and move on to Eric. So Eric is on the Open On Demand team, and what are the challenges that Open On Demand faced involving interoperability of CI? And what opportunities do you see for solving some of those challenges with the SGCI resource catalog?
Yeah, so as you probably know, On Demand is a portal to provide general-based web access to HPC resources. And I want to tell you about a problem that we have in Open On Demand. I believe the SGCI resource schema will help fix. So On Demand interactive apps are plugins that consist of a job template and configuration files. The configuration files are used to generate a web form that the users submit to submit a batch job. And then the job template specifies how to start the particular application, whether it's Jupyter, MATLAB, or RStudio, et cetera. So these plugin files contain site-specific hardware details. For example, our Owens cluster at OSC has regular nodes and GPU nodes, both with 28 cores, and large memory nodes with 48 cores. And a user of our Jupyter app can select what node type and number of cores when launching the app. So there are 2 problems with this. The first is that site-specific hardware resource details are duplicated across all of our apps at OSC. So MATLAB, Jupyter, VMD, ParaView, all these apps know how many cores Owens have and what nodes they are. types are available. And then the other problem is when another HPC center installs Open On Demand, they have to copy our plugins and then modify them with their own hardware resource details. So as you can imagine, this creates installation and maintenance difficulties, and it also slows development and sharing of new on-demand apps. So to fix this problem, we want to pull out the hardware resource details into a configuration file that can change from center to center. And defining a configuration schema that accommodates the variety of hardware resources at different HPC centers is a difficult problem. But that's why I'm really excited about the SGCI resource schema, because that's the very problem that's being solved. So we're interested in looking at adopting it for the cluster configuration and on-demand. As for remaining interoperability challenges not addressed by the resource schema, we're still going to face challenges interoperating with different batch schedulers excuse me. And we also face challenges dealing with a variety of ways to launch individual applications like MATLAB and Jupyter. But there's also a proposed application description schema that hopefully will be worked on after the hardware definition schema is complete. And so hopefully that will address those problems. Now, there are 3 challenges that I believe we have in effective adoption of the schema and on-demand. So the first is that defining the available resources at a center is different than defining the subset that should be used by a particular app or portal. So for example, at OSC, we have an on-demand instance for classroom use where students can launch Jupyter, but they're not allowed to specify the node type or the number of cores. So we either need a way or just guidance on best practice to enforcing portal-specific constraints on what is defined in the resource definition for a resource. The second thing is that we would like to add portal or vendor-specific configuration to the schema. And I actually don't know how that would work with the plans for kind of the shared resource definitions, but definitely a lot of open on-demand installations. We have a lot of situations where we want to add a configuration for a particular resource that's already defined in the schema. And so it'd be preferable to keep that all in one place instead of spraying across multiple files. An example is file system definition is part of the schema. And we would like to maybe specify the interface to use when modifying access control lists, POSIX or NFSv4. Unfortunately, right, this determination is based on what the host of the portal is installed on and how the file systems are mounted, rather than a general property of the file systems themselves. So there are probably other examples of those type of configurations that might change from portal to portal. This is an example of a more general goal, is that we want to ensure that on-demand doesn't become more difficult to configure. And actually one solution that might help with that would be supporting YAML. Now, obviously that introduces some complications since the JSON schema is what's being used right now. But we are definitely interested in exploring options there.
Well, thanks for explaining some of the open on-demand requirements. Next, we'll go to Tomas. So Tomas, you were involved in the beginning of OGF, the Open Grid Forum standards development. What do you think worked well and what did not? And what can we learn about interoperability standards to ensure we get it right this time around for adoptability?
Definitely. So I think what's very important, and we heard it in the presentation as well, is that these standard proposals did not work out particularly well in the old times. And it had different reasons why they did not work out very well. So if people were around in the grid computing era, then they found that all these standardization efforts started with very big hopes, and most of these efforts did not really result in a standard which was widely used by the community. And I think what is the biggest challenge in standardization is not necessarily defining the standard or to defining what you would like to kind of suggest for the community. The big challenge starts once the standard is in place, and then you start investigating how this is taken up by the community or how the different implementations are using this. And it was also mentioned in the presentation that new technologies put kind of new hope into this, and the old times were not successful because they used different technologies. And to many extent, this is true. So all of these early standards were XML based. That was much more complicated to describe the various aspects using XML. We heard that this is a JSON based schema. YAML was also mentioned as a potential a kind of way of describing it. And I agree that this makes it probably much easier to define the standard or to come up with something which is meaningful. I think the big challenge will be is that how the different resource providers are going to support the standard and what kind of solutions will exist for the kind of wider community take up of the standard. And we also heard in the presentation that you are trying to keep it small and you try to concentrate on the most important aspects, which I think is good. But then it will kind of naturally result in people starting to extend this and starting to come up with their own custom-made extensions to these particular standards because certain aspects are not covered by the standard. And then you can end up in many different dialects and many different not 100% interoperable solutions. So I believe that these are the kind of biggest challenges which I at least learned in the past decade or so when I was dealing with standardization efforts. And I'm very happy to hear this. And I think this is something quite important and would be quite interesting to explore how this work can be, for example, carried over to the other side of the pond and how in European science gateways or European solutions we can use something similar. But again, I also aware of the challenges and I think you have a quite long way ahead of you. So this is in very brief what I think I can contribute. Thanks.
Thanks so much. It's really great to hear your experience going back to Open Grid Forum and really kind of how to avoid the pitfalls and really strategize appropriately. So I'm going to go ahead and take some questions from the Google Doc, and then panelists can feel free to just unmute themselves and answer. So one of the questions is, what are your experiences interoperating CI components, and have you worked on projects where there was a requirement to bring together resources from multiple CI systems? And I'll give you guys 5 minutes and then we'll move on to the next question. JP, do you want to start first and talk a little bit about bringing together multiple SPs and as far as kind of getting information services?
Sure. So one of the things that Exceed is able to do, thankfully, because we're a federation and we have some standards that we can apply across the systems that participate, is we were able to identify what are the information related requirements for participating in Exceed. And people often think of, you know, we have standard login, standard user credentials, the standard user portal, this sort of thing, but people don't see as much that we actually impose on the service provider some requirements about information publishing also. And that has been very helpful because in our environment, we can say, if you want to be part of Exceed, here's a required element that you have to provide, right? You have to go into a resource description repository and you have to describe your resource. That is how you get your foot in the door. If you're not listed in our resource catalog, you're not part of the federation, right? That has worked really well. And in fact, turning that information over to service providers and making them responsible for maintaining it is a goal that we aim for, but we also struggle with because they're sometimes not keeping their own information up to date. And the same thing goes for automated publishing. We tell them, you run an HPC resource, you have to run this piece of software, and it has to publish everything about your scheduler to Exceed. so that Exceed knows as a whole, what are all your queues and what are all the jobs that are in all your queues and how busy is your machine, okay? And that's a really nice thing to be able to do in a federation, and to then have the user portal be able to display all of the resources and how busy they are, for example. So that's been sort of our experience. We come from an environment where resources have to do things to be part of the federation. We have resources that don't have to do it, and most of them don't. And those are what we call level 3 service providers. And it would really be nice to make it so compelling that service providers that don't have to do things still choose to do them for the greater good, but that doesn't happen often.
Any other panelists want to chip in?
Yeah, this Suresh, I'll just add that like JP gave a nice motivating use case here for the resources itself, the computational resources, but from the gateway layer.
We just lost your sound for a second there, Suresh. No, can't hear you. All of a sudden it just went out. That's weird. Oh, wait, maybe I hear you now. Say something. Oh, no. I thought I heard your mouse.
The tech gremlins have creeped in. And
I'm sorry about that. Can you hear me okay?
Yeah, we can hear you now.
Yeah, I just want to add that in addition to the gateway resource description layer JP mentioned that does exist for gateways, there are simple trivial things like, oh, I see this application being existing in a different framework, or like I would like to use it, or this real example we've been looking into. Let's say a University of Hawaii researcher comes in and tries to use a gateway developed in Airavata, and then we know that the TAPIS already works on that cluster. So is there a way we can simply query that or leverage that description instead of figuring out again and so on? Or you could apply to a different application. Let's say once we move into the application description, a gateway framework has worked all the way through in describing that application. Can we just leverage that? So what we are trying to say is this lowest level of what gateways operate, if we can make a community, the gateways can spend their time instead on the higher level core value proposition pieces instead of repeating the full 9 yards, like all the way through. That's an example what we've been motivated with ourselves.
Yeah, and just to kind of echo that, and also something Eric said earlier, right? With our project TAPIS, we see a number of projects, tenants in our multi-tenant platform, redefining the same set of resources, right? The same set of apps, the same set of resources over and over again, and manually doing so. And so, sometimes there's a little, sort of iteration that has to happen because they get it wrong the first time, and so one of the goals, one of the motivations here is to do away with that. And we are, as part of the new version of TAPIS, trying to define, we're actually working on now an endpoint that could allow you to import a resource definition from the SGCI catalog. And that's a way in which it can sort of be automated and take away this sort of duplication problem. So yeah, just wanted to add that as well.
Also, just to add, for Open On-Demand, we often have sites running different clusters with different schedulers. Our own site, we have an adapter just to launch processes on arbitrary Linux hosts that we're making use of, along with a Tor cluster and a Slurm cluster. And we're going to add a Kubernetes in the next few months. And so we definitely have experience trying to interoperate with a bunch of different CI systems.
Okay, anyone else want to chime in? Otherwise, we'll move on. Okay, next question. I think this is more for Joe and Suresh about having a reference implementation as a guide for the new framework CI component so that APIs can use it effectively.
Yeah. In the Google Doc, we already answered that, but just want to echo that what's written there is, so there are two parts of the reference implementation. One is the schema itself, and how do we create a reference implementation? That's what we intended to with the surveys, how we can pull that and use that. But if the surveys of interest, and if you're looking for examples on how the various frameworks are integrating, the TAPIS, Airavata, and Hub0 are actively working on that integration, like now, which all of us respectively are targeting by end of this year going to production with this SGCI schema as a dependency, and we'll be happy to share those requests. So if you can provide, create an issue, we'll be happy to share, put pointers to how we are using the service as a reference implementation.
Okay. Next question is, do you have a set of use cases or personas for people, teams, and applications that will consume this information in order to achieve something not otherwise possible, or perhaps existing firm user requirements?
I would say that those are just kind of evolving. I mean, I would say that our use cases are your use cases, really. I mean, and I'm not trying to be cheesy there. I mean, that's really the truth, is that the whole point of this is interoperability across science gateways. And so, we do have, I mean, some use cases for sure. I think there's some, we've actually written about this a couple of times. There was a paper at PERC as well, a sort of an earlier, kind of more preliminary paper, which we linked to in the Google Doc, that has some use cases. And we've been doing sort of deeper dives with some of the frameworks, some of the technologies in the Tech Summit. So TAPIS, Aravata, Hub Zero, to kind of firm up use cases from those vantage points, from the viewpoints of those technologies. But it really is the open on demands and all the other gateways that are out there. It's their use cases as well that we want to capture, and to the best of our ability, make something that can work as broadly as possible.
Yeah, great. And as Joe said, really kind of what we're looking to is the community. If you have use cases that we haven't addressed, or you have a software application that you think could potentially benefit from this, I would encourage you to, come to the Learning Lab or reach out directly to Joe and Suresh, and, let's have a discussion and figure out what integration opportunities there are, or, to integrate your use cases. As Joe said, this is a community effort, and the big goal is to have the community also be both adopting and contributing to this project moving forward. There's one more question being typed. It seems resource descriptions are tied to account management. Is that something that is part of this schema?
So this Suresh, I'll start with that. So no. So we intentionally wanted to keep it out. So because every gateway framework or other application you may want to develop, it might have its own proprietary way on how the account management is managed. Since that's, so this is the starting step where we wanted to keep it the really common descriptions, which could be stored in a Git repository, and wanted to have the frameworks have their respective ways on how they attach credentials to these descriptions. So no, we are not intending the security as part of the schema to start with, but we just will have what security protocol these resources support, what credential, what kind of the supported credentials and so on. But we expect that the respective gateway frameworks will have their own way on how to manage those credentials themselves.
Joe, anything else you want to add?
Yeah, no, that was great. I just would say that this point that Eric brought up about kind of portal specific constraints on resources. This is also a real thing. So it's not exactly what the question asked, but it is something that we will need to tackle. Because you have a big resource that has lots of queues, lots of hardware, and then you have portal specific requirements on what can be accessed within that. And so some kind of good way to capture that is going to be needed. And so that's sort of still a kind of an open question. So there's still lots of open questions about this stuff. But yeah.
I think this will be our last question. I think it's probably more of a Daniel question. So more of a Hub Zero specific question. Could you comment on what, if anything, would change for current Hub Zero gateways with the use of this resource?
Let me share my screen. Can you see my screen?
Yep.
So basically, in the implementation of the Hub Zero, we are using the resource inventory to get the available venues. So we save the venues that we are interested in a specific hub when the hub is installed or the manager want to add a new hub, a new venue. But then since we are talking the same language with different systems, we can now integrate with TAPIS to register that resource or venue on their system and use that system as well to submit all the jobs and be managed by the TAPIS framework. So that's what we are aiming from the Hub Zero point of view. So it's not going to be any change for the final user, but internally, since we are talking the same language, we are doing completely different interoperating different cyber infrastructures.
Right, so we're almost done with time. Again, as I said, there's a Tech Summit Learning Lab right after this plenary. I really wanted to thank all our panelists for taking the time and showing up and contributing your ideas. In the Google document, there's a takeaways section where you can feel free to add some of your takeaways from this session. And I think Catherine just has a few parting notes for us. Thank you, everyone.
Yeah, I just wanted to add that if you're wondering where to find the learning labs, in case you didn't participate in any yesterday, I know a few people had trouble finding them, and they will be in a half an hour from now. So you have a half an hour break to stretch your legs and whatnot. But if you're here in the Wednesday conference sessions, and here we are officially in the plenary, just scroll all the way down, go past the sponsor booths, who you should visit during the break, past the Meet Me at the section where you can hang out, and then here are the learning labs listed at the very bottom. So I encourage you to join that. There are also 3 other topics if you want to check those out. And those are all described. You can click this link here at the top where it says Learning Labs to see them listed individually and the descriptions and who's hosting and so forth. The other thing I want to point out is today's schedule is flipped for the second and third hour from how it was yesterday, and tomorrow will be like yesterday. But so concurrence will be following again then after the Learning Labs end. The Learning Labs are 50 minutes, 50. Followed by a half an hour break, and then at 3:50 Eastern, whatever that is where you live, but 10 minutes before the hour of, there will be these 2 concurrent sessions on biomedical research and education and communication. So I hope you'll all consider attending that as well. That's it. So hope you have a good break, and thanks, Lee, for your for your sign.
Bye, everyone. Thank you.
Thank you.